This program is a presentation of UCTV for educational and non-commercial use only.
Good evening and welcome to the Birch Aquarium. I am Nigella Hilgarth, the Executive Director, and it's a great pleasure to welcome you to the latest in the Jeffrey B. Graham Perspectives in Ocean Science series. And it gives me great pleasure this evening to welcome our speaker, Dr. Hubert Staudigel. He's a research geologist at Scripps, and he has been on some amazing adventures himself. And this evening, he is going to talk to us about some very important research he's been doing in Antarctica. And in order to get the data for that research, he has gone to some amazing parts of Antarctica where very few other people have been able to go. I myself have been to the Antarctic Peninsula, which is really just the gateway to Antarctica. And one day I aspire maybe to go to some of the exciting places that Hubert is going to talk to us about tonight. So without further ado, I'd like you to welcome Dr. Hubert Staudigel. Thank you very much.
Before I start, allow me to introduce some of the people who I'm working with. There's Laurie Connell. Laurie and I met 6 years ago in Antarctica, and we have basically sort of dreamed up this whole project. Just before that, I have been working with Alexis Templeton and Brad Thibault at the time, who were here, and set sort of the microbial foundation for this work. And the current students, and this is Lisa Sudek, she's in the audience, and Brad Bailey, who recently finished his thesis in fall. I would like to acknowledge here the Argoron Foundation, which is supporting much of this work. And what's remarkable about Argoron is that they gave me money for some relatively high-risk research that I couldn't have done with NSF without it. And as I was doing this work, eventually I got proposals funded, like this one here, and then I can actually get NSF to pay for this work. Also, I would like to point out to this website here, a lot of the slides that you see tonight, you'll be able to download straight as high-resolution files from this website. Now the title, Life in the Extreme, the Rock Bottom of Antarctica's Food Chain. There's a lot in there. We're talking about the bottom of the food chain. And the bottom of the food chain is the place in the food chain where life is built from the original chemical components. And then as you go up in the food chain, this life is eaten by others, and go on to finally to the final predators. I'm talking about the rock bottom, which means that this part of the food chain actually is attached to rocks and draws some nutrients from these rocks. Now, life in the extreme is that we chose Antarctica as the site after we've been working for this for a while, because everywhere on Earth, there's actually a lot of life around. So microbes that may use energy from rocks actually can eat other things as well. You know, just like look at your teeth. If you eat lots of sugar, guess what happens to your teeth? These little microbes just drill holes in it, right? But that doesn't mean they have to do that. They just do it because they live so well, they produce all this acid, and then they can get some additional goodies. But they don't have to live off these teeth. So what we're trying to do in Antarctica is go to places where there's no other organic material, where the microbes can actually have to eat the rock, right? And it's a long-term project. This year we just went out, or this fall we just went out to put out experiments. 2 years later we come back and get the first timeline, and then 4 years we come back again to get the final timeline on these experiments. The goal of these experiments is to look at substrates, how they are etched by microbes, and what microbes are sitting on these substrates. So in this talk, what I want to do is I want to first give you some background and why we think that microbes eat glass. And then once we're done with the background, then I just take you on a slideshow with lots of pretty slides from Antarctica. So one thing that we are working on is volcanic glass. Volcanic glass is formed when lava quenches so fast that it doesn't form any minerals. So it makes a glass, like the glass in the window panes. If you cool these window panes slowly, they will be milky. So they will form crystals and they don't form glass anymore. So this slide here is a section, a microscopic section through glass with a crack through in the middle. And then when you look along this crack, you find these spherical cavities on both sides. And we interpret those things as features that are caused by microbial etching. Here, these little spherules agglomerate into almost like what's like a microbial growth on an agar plate. So this type of alteration we call granular alteration. Here we have another slide through volcanic glass. This big feature here is a vesicle or a bubble in the glass, which is filled with clay minerals. And then there's a little crack that goes to another crack. And so at some point, this bubble was filled with water. Microbes sat on the surface here, and they drilled these tunnels, micron diameter, 100 micron long. There's another feature. So here we have these tunnels that bifurcate, and they form like a dendritic type of feature. And the reason why we image all these different features is that eventually we want to figure out which microbes do this. And so by mapping out these trace fossils, we can actually eventually find, hopefully, the microbes that do this. Now, this is a helix or a corkscrew. Those kind of things are very difficult to do without microbial activity. Again, a microscopic section of glass. Here, a very complex tube. You have a central tube with one that wraps around it later. Now, this is a very interesting slide. It's very confusing probably for you at first, but I'll go through it slowly. So these are two thin sections. This one is from the Pilbara Formation, Australia, in 3.5 billion-year-old rocks. 3.5 billion, that is 1 billion year less than the age of the Earth. They're very, very old. Here we have another one from the Barberton Mountains. It's also 3.5 billion years old. So now here you see the outlines of an old glass shard, like glassy sand, that formed 3.5 billion years ago. And then you have these minerals here that seem to form these tubular or features into the thing. And so I take this place here and blow it up to here, and you see there are all these tubular features that were formed because we could age date this 3.5 billion years ago. And then it's the same thing here, except for it's in South Africa. It's not as well developed. A crack, and then we blow up this feature here to here, and you see how these tubes go into the former glass. Now, what we learned from this is that we have these linear features in the glass, and the only way to do this is by something that fungi do very well. They have hyphae, little cell extensions that can actually drill into rock, and they provide nutrients to the rhizome of trees that are growing above. Now, one of my students, Lisa Sudek, has isolated microbes from an active volcano down in the South Pacific. And this is Pseudomonas stutzeri, and we cultivated this. And under nutrient-limiting conditions, these microbes settle on, in this case, volcanic glass, and they attach themselves with features like this, right? And so these cell extensions, we have no idea what they do at this stage, but we suspect that at some point we find out that they play a vital role in dissolving that glass. Now, there's another interesting slide that Yuri Gorbia and Greg Wanger gave me. This is Shewanella. And they make these really tiny little strings. They're like a few nanometers across and hundreds of nanometers long. And they manage, and it's absolutely incredible, to measure the conductivity of these little strings. And they're conductive. And anybody familiar with microbiology knows that microbes need to move electrons around. They need electrons, or they give away the electrons they need to get rid of. And if you have a nanowire like this, that's a fantastic way to get rid of electrons. But those things also, being electrically conductive, could in theory be little sensors that microbes send out at almost no cost and probe the environment. So they don't have to send a whole hyphae out, but they can just send this thing out, find out what it is, and then start mining it while they know what it is. This is an interesting study from Golubic et al. What he did is that he looked at dissolution of carbonate. And what he did is that they take like a mollusk shell that has drill holes in it, they impregnate it with resin, and then they dissolve away the carbonate, and then they get these features. So yes, we find tunnels associated with fungal hyphae. Yes, we find cavities in the carbonate that resemble the shapes of very particular fungus. And it's this guy. So we can use these features to identify the microbes. This is the same thing, but in silicate. Jongmans found this in feldspars, and here you get an SEM picture where the hyphae goes into this feldspar. This is a model how this would work. You get a cell that occupies a surface, and it excretes acid, dissolves it, makes a spherical cavity, and then it has a house. It divides up and makes more cavities and so on. Or you have a fungal hyphae or a cell extension that does the same thing, drill, and then it can drill vertically into glass. So that's our model. Now, these are the type of features, I don't know whether you can see this very well, but these are the type of features we observe in nature. And one of the speculations that I have is that these helixes on top of those may be something like a nanowire that wraps itself around a tube and then has like a sensor function or who knows what it does. But we have to have two types. We have to have two types of mechanisms to make these complex shapes. Now, this is a map. I don't think that comes out very well. The conclusion is we find these features everywhere. In young oceanic crust, in old oceanic crust. We find it in the oceans. We find it where we have submarine volcanoes uplifted on land. So it's very common. And it exists all the way through Earth history. So it's this thing that we are going after as we're going to Antarctica. So this is Ross Island in the Ross Sea. And I'll tell you about, there are several sites we visited. This here is Lake Frexel. This is Wolcott Glacier. There is Cape Evans. Up here is Mount Erebus. And here, this place is the end of Hut Point Peninsula. That's where the McMurdo Research Station is. And in the beginning of the season, all this is ice. So here you have, get yourself onto a skidoo, a snowmobile, and then all this country is yours. To go here and there, you have to go by helicopter. So here's how we get there. It's the C-17. This is the deluxe version of a C-17, which actually has seats in the middle. In the back, you see the freight. Normally, this whole thing is filled up with freight with people just sitting on the side. That's an Air Force operation out of Christchurch in New Zealand. So here we emerge from the airplane. This is the C-17. And just notice that there are actually wheels. So to land this airplane, you need ice. You cannot do that on a snow runway. For this reason, McMurdo has at least 2 airports and often 3 airports. One seasonal ice runway near McMurdo, and then one long-term runway that is 45 minutes away, and then a snow runway for the ski planes. So this is the old runway with the C-17s. In the background, you see the Royal Society range. And here's your transportation, Ivan the Terror bus. That's the bus we take from the airport to the station. Now, this is not from Ivan the Terror. This is actually from a helicopter. So we're looking at McMurdo Station. This is Old Town with Scott's Discovery Hut. This is the harbor with the ice pier. And this is part of the beauty of McMurdo. In the background is Mount Erebus. And these are Delbridge Islands. And we're sort of going to, I'll show you some slides going along this way, along this coast with the snowmobile. So this is McMurdo in all its beauty. It's 1,000 people living in these dorms and being fed in this cafeteria. And actually half of that is also dorm space. This is a low rent income place where people sleep in bunks, in rooms with 6, all bunked up. It's not a very pleasant place to live, very noisy. This is a helicopter landing site. Here are some more dormitories. This place, for our interest, called is Hotel California. And this is a great place to be because at 3 o'clock in the morning, they rev up the helicopters to get them ready for the day. Your whole building shatters. It's just wonderful. I never stayed there, but it's well known. This is the Crary Lab. That's where it's it's a wonderful laboratory where you can do all kinds of research, biological, chemical. There's computer, internet, everything. Now, this is Old Town. That's Scott's hut. He used that hut on his ill-fated expedition where he basically didn't quite make it to the pole. And I'll show you some pictures inside. So basically you go up and take the key and you check out what he left behind. It's very informal. Actually, recently they started training you as a guide, which I am now. And so you can look at all these relics. And that's where those guys lived. Note that everything is very black, and it's because they used seal blubber to heat. And so that's the seal blubber. So there's still some of the stuff lying around. It's not very appetizing. So this is our mode of transportation out of McMurdo. This is Lori Connell, my co-investigator, and she went to Antarctica with me. And that's me with my big rig and sled. This is actually from a couple of years ago when we did a paleomag study with Lisa Tokes and Cassie Constable. So you drive a little further away and you come to Shackleton's hut with Mount Erebus in the background. This is much more livable. They stayed there actually for 2 years. That's his stove. Everything is beautifully preserved, and some candles to light up in the winter time. During the summer, you don't need them. They had some salt left, and pretty well stocked. They actually had laboratory space where they studied and did experiments. So, and wherever you go, there are these Adelie penguins. They're just adorable creatures. They're walk funny, they're lively, they're really interesting. As opposed to the emperors, they're just boring. So here's another one. And the thing is, the etiquette in Antarctica is that, if you're a penguin researcher, you can do anything. You can abuse them, you can catch them, you can squeeze them and inject them and all kinds of bad stuff. But us, we have to stay away and get closer and closer until they start reacting to us, and then we stop. And then actually, sometimes you take a lunch break and like this fellow just walks up to you. They walk right by your sandwich and look at it, and then they, very, very curious little beasts. They're, really a lot of fun. So it's close up. And that's a rookery. That's on Cape Bird. So they built these little nests out of rocks and dung. And they sit it, and they actually have to incubate these eggs in really frigid conditions. Eventually they're successful, and those little youngsters, they're smart. It's cold outside. It's warmer in the feathers of their parent. So when they're that age, you never see the whole beast. They're just hiding within the insulation. So these guys are practicing for next year. So more Adelies. Yeah, so this is a skua. Skua are the nemesis of the Adelie penguins. And they roost right next to the penguin colony, just right there. And I keep on thinking the penguins are really stupid. They should just go there, kill their eggs, and then they can bring up their own young. But now those guys lay their eggs. They, this is basically a seagull, big fat seagull. And then they're sitting there while like 5 yards away, you have the penguins roosting. And about the same time, they have their chicks and they have their chicks. And we know already that some of her chicks will eat those chicks. Just all part of nature. That's how they do it. But they're beautiful animals too. So now this is an animal you don't want to meet. This is a skull of a leopard seal. Leopard seals are almost more like snakes than they are like seals. Very long bodies. And I'm going to show you this picture because I want to show you his teeth. So they have really, really steep incisors. So those are things that you don't ever want to see coming towards you. And they basically are mean. And what they do is that they drown people or seals, and then they just thrash them into pieces, and then they eat them. And then if you look at the teeth here, just look carefully. These are not normal molars. So those are too delicate for them to actually crunch something with or to chew something with. And those molars are actually little, they're for sifting krill. So they can actually take in water with krill and catch the krill in those teeth, and then also eat the smallest kind. The large prey, they basically have to tear apart into pieces and they swallow it as a whole. But I thought it was very interesting that they're both made to catch really big prey as well as small prey. So now is the picture across to the Royal Society range. Now they're seals, and you will have to suffer through a bunch of seal pictures. This guy is like 2 or 3 weeks old at the most when he was formed, when we saw him. So they grow pretty fast, nurtured by their mothers, milk. So they're just, I just believe me, this is only like 2% of my seal pictures. So, so it's very hard to pick ones that you want to show them all. And so those guys, this is actually, a bad picture to take because what that means, you're right next to that hole. If you go swimming with those guys, you had it. It's not a good idea. So be very, very careful when you're next to these swimming holes. So, but they're very, very cool animals. So they show off too, I sit there and just with my camera, long telephoto lens, and this guy just performs, So, and sometimes you get some big seals too. So, but to give you a scale, so what I did is I took another picture, picked these people for a scale, and put them in that picture, and then you see how big that seal really is. So be careful when you go to Antarctica. Those are some very big seals. So now the first thing we had to do, actually, Laurie did this, we had to make our logo. So this is the microbe. And the microbe eats rocks. So and we have a flag and everything, so that was and then we had to do some work in the laboratory to set up our experiments. And, basically what we do is we brought glass powders of various compositions that give different kind of nutrients to potential microbes that would be interested in them. And then we sew them up or we actually flag them and we put them into little sachets. We have also thin sections, polished sections, so we can have a reproducible surface. And we put them into this basket, close it up, and then we have these bigger experiments, which are granular volcanic glass in it. And then we just put this into various places. So now we're going to go all through this area and look at these places. So this is Cape Evans, and that place was chosen because we have a steep rock wall that goes way down vertically here, and then here we have a glacier right next to it that comes in. And those guys put up a little hut, and we went. It was kind of a cold day out, but then you get into the hut and it's all cool. It's also nice. It's heated. There's a hole for the diving. This is Rob Robbins, the dive master in McMurdo, and those guys deployed those experimental charges for us. See you later. We're going to be going down there. This is the hole. So these are not slides from this particular place. I just chose them for the beauty. Here's a glacier that goes into the ocean, and so it throws up this moat. And there are scientific studies going on in those glaciers. This actually is a data port coming in where they have on top of the glacier a wire coming into experiments that are going down there. Beautiful place to dive. Very cold. Now this photo, I picked this is to give you an idea of what the ice looks from underneath. And it looks almost cloudy because the ice is clear in some places. That's where the light comes through. And then the ice is dark where you have snowdrifts. So it's a very eerie, almost thundercloud kind of atmosphere. But then you get these funny icicles here. So what happens is that as ice forms, it's sea ice, it's salt water. Now what will freeze is relatively fresh water. And that forms like a very loose network of ice crystals. And between those ice crystals, there's a brine, a very saline, salt-rich solution in between. Now, as the ice grows, it rises above the sea level. And then this brine that is exposed to the really cold winds outside will filter through into the seawater and then basically freeze seawater as it enters down the seawater, okay? So, and forming these stalactites. So this is actually formed by salty solutions from the ice seeping down and then freezing seawater and then coming down. It makes just fantastic shapes and looks beautiful. So these are our experiments that we put on a rock with some weights, and we already have some guys interested in what this is. So we'll see what happens. Now this is the Erebus glacier tongue. That's a place we have to go by on the way back from Cape Evans. Cape Evans is over here, so we take the skidoos through the Delbridge Islands by the glacier tongue. And then the glacier tongue is basically glacier coming into the ocean, and it sort of feathers out and covered with snow. But then these feathers, you have snow, and it covers these feathers, and it makes these snow caves. And it just makes some, you go in there and you see some really cool patterns, and the photographer in you just goes crazy and keeps on going. Now, this is our second place where we do experiments in the dry valleys. The dry valleys are called dry valleys because they're very, very dry. And what happens is it's so dry that all these glaciers coming in from the side dry up before they meet. So this is bare rock, which is rare in Antarctica, but here it's so dry that the glaciers just cannot fill up this valley. So what happens is that those glaciers come in the summer, they melt, there are summer streams going down, and then they're filling up these lakes. This is Lake Bonny. And so what our interest was is, number one, is to look at these streams that come down and see whether these streams, particularly when they come from a volcano, whether those streams carry any interesting microbes. And then we wanted to drill a hole into these lakes and put a mooring in. There's some very interesting chemistry down there. Some is very oxygen deprived, some is rich in oxygen. Very interesting chemical variations in the lake. So we decided to put a mooring in there. Now, the glaciers in Antarctica are cold-footed glaciers. What that means is that they're stuck on the ground, right? In most of the northern hemisphere, most glaciers are wet-footed glaciers, where the glacier actually slides along the bottom, and here they're just stuck to the bottom, right? So what happens then is that the surface moves, but the bottom doesn't, and in between moves a little. So that's why you get these very steep fronts, Very characteristic for the Dry Valley and actually many of these glaciers in the Royal Societies. And then the ice falls down, and down here it sort of starts melting and feeds those streams. Now, another thing that Antarctica, the dry valleys, are famous for is vent effects. And basically, winds are very, very strong in Antarctica. So those winds are carrying sand and little rocks. And the sand and the rocks will start eroding the rocks that are sticking out. And they're eroding them in really cool shapes. You know, this is a vent effect, right? So it drilled these holes, and you can look through, and you see the Ferrar Dolerite in the back and the Taylor Glacier. And it has these long, tongues sticking out just in the middle of nowhere. And, and those things form over millions of years. You know, those dry valleys have been like that for at least 10 million years. So those are very, very ancient features. Well, another thing that happens is that every now and then some seals lose their way, and they're not making it. So you find mummified seals. And it's kind of eerie, but you just walk along and you all of a sudden run across this guy. So poor guy, so what happened? This is Lake Frixell and the Canada Glacier on the back. We're looking out from the helicopter landing site for the station, and the next picture shows you the station where we stand. So this is Lake Frixell Camp. This building here is a building where you cook, you eat, you have internet access, all kinds of stuff, and fantastic place. And then you have a series of laboratories. You know, they're specific for water chemistry, for electronics, for radio lab, and so on. And then out here, you pitch your tent, you sleep out there, and then you socialize in here. These are the tents. This is mine. So one of the chores you have living in Lake Frixell, you have to get water. So what you do is you go to Canada Glacier, and then you collect what they call glacier berries, which are the ice chunks that fall off the glacier onto the ice. So it's pretty clean water. You put it in your big bucket on your four-wheel drive. They're fun to drive. And then you bring it home, and then you melt it on the stove. So that's Lori. We're on our way to our drill site, where we're going to man drill a hole into very, very thick ice. Now what happens is that you have all this water coming in the summer months, the austral summer months from the glaciers, and it keeps the lake up. And the water sinks in, and all through the year, the winds ablate or dry up the glacier from the top, right? So the ice grows on the bottom, and it evaporates on the top, right? And so because of this evaporation process, you make these really interesting features, and again, you as a photographer, you just love this kind of stuff. It makes great screensavers, and you can see people and all kinds of fun things. But then you have to work. So this is an auger drill. It comes with meter segments of drill augers. And if you have 1 meter, it's no big deal. You just have this lawnmower with this funny bit on the bottom, and you drill a hole. No big deal. But at some point, this whole thing turned out to be 6 meters in the end, so we had to add many, many segments. Now, there's one problem, is that during the winter time, the ice has grown to be extremely cold, right? Because you have these minus 40, minus 60 degree temperatures in the wintertime. And in the summer, it takes a while for this ice to catch up. Now, at the bottom of the ice layer, the water is just about freezing, right? It freezes on top, it freezes up there. And so what happens is that you have water that is just at the freezing point. You have ice that is well below the freezing point. If this stuff mixes, right, your drill bit is frozen and you've had it. Then you have to sort of end up digging out this drill bit. And so what you end up doing is you have to move the drill bit up and down, and expel the shavings as much as you can, and keep it very dynamic, which is easily said at first, but once the thing ends up that long, you have a hard time. Anyway, we succeeded, we drilled that hole, and we were very proud. that we managed to do that, and then we can do our mooring. So there's a little metal weight that goes on the bottom, and then there are all these charges we put in there, or baskets. And one after another, we have 3 different depths that we put the stuff, and then we put a flag on it, so we find it the next year again in a pallet. And this pallet will protect this ice from evaporation. So when we come back in 2 years, this will be actually a high point, right? So we actually, because the rest will be drying up around it. So we'll have to go on top of it and figure out how we get back into there and get them moving. But that's for us to figure out then. So this is our other site. We chose this little stream here in a basaltic lava flow, and we figured we put something down there in this little stream. Those streams are active only for a very short time in the summer. And sure enough, when we got there, it was all still frozen, and we just had to, it was kind of tough, you know, how do you determine where to put it? So we figured, well, we just take a deep point and chose this site, and we wrapped it in gauze so the stuff doesn't gum up with sand, and then covered up with snow, hoping that it will work. We have a temperature probe in there, so we know how long it was exposed to water and how long it was frozen. And we give it 2 years and another 2 years, so maybe after 4 years we see something. So this is one of those glaciers with those steep fronts that I showed you before. So now that's on the way back. As we take a helicopter back from dry valleys, we can look across to, 40 miles across the sound to Ross Island, and this is Mount Bird, which is the northernmost volcano, and that's where, right here was the penguin rookery that I showed you a little earlier. So now, it's like a tableland. You have these pieces of ice shelf that are sometimes frozen in, sometimes floating around, but this is just the subaerial part, the above water part, right? And so it's like almost 8 times as much down there. So these are huge monsters. And you can fly your helicopter around it, and then you see these cracks, and along these cracks you always find these seals. So whenever you have seals in Antarctica, you have to be careful, because that's when you might fall into something you don't want to fall into. So at the edge, sometimes you get these crowds of emperor penguins who seem not to care. I mean, in this particular case, we were hovering with the helicopter. We're not even landing. And they're just sort of, cool, yeah, let's go to business. And this guy was actually a different place. But, you can see how boring they are. They just sit there. This whole session, I took like 100 photos of this guy. And the session took like an hour, and he just didn't move his legs at all. I mean, just his, he just did his thing. They're really beautiful animals, but they're just sort of very emperor-like. So minke whales from a helicopter, and then more penguins. Now my favorites, the Adelis. That's also in Bird Peninsula. And this iceberg just basically grounded there and is sitting there for 2 years now. So that was actually 3 years ago when we were working on these basalts. It's kind of a tricky place to work because you don't want to slide down the snowfield. It's not good, but it's gorgeous. I mean, you see these funny snow ice islands that are rounded from ice moving around. They just rotate and get round. And then you get these beautiful views. It's very nice. So now when you come close to shore, if you have long-term ice, the ice actually moves with the tides. So it bunches up. So it makes a very interesting photographically place, but also kind of challenging to maneuver through if you want to work there. So, but I mean, photographically, these are wonderful places. This is not coming out very well, but what I took here is this, if you see these blue spots here, you look from the other side, this is blue ice. This is not blue sky, this is actually blue ice. And our skua dancing. And these are some of the means of transportation that you use on the ice. Now we're going to the Royal Society Range. The Royal Society Range is part of the Transantarctic Mountains, and it separates the big ice sheets in the west from the East Antarctica. But then the ice sheets are going way up, high up with respect to this mountain range. And then you see this ice spilling over towards the east, down into Ross Island Bay. And so this is one of these glaciers that we went to. And so basically this stream here drains this glacier. It's called Wolcott Glacier. And so we went up there to do one experiment. So it's, we were still pretty early in the season, so most of it was frozen. But then once we started hacking at it, these holes filled up very quickly with ice. So we put our experiments, we bring them in sterile in aluminum foil, and then so we put them into these holes. It will be in here, and it will be secured to the rock to find it back later. So that's another shot from the Royal Societies. This beautiful glaciers, this cascade that I showed you earlier. These are the Ferrard. This is rocks that intrude into these mountains. So now one of the things is when you go to many different places, you have to go through all kinds of training. And so this is our crevasse training exercise. So we have to figure out how we rescue each other if one of us happens to fall into crevasses. And you have to deal with ropes and learn all this stuff. And then, when you're ready, you just pack all your stuff into carts and hope that it all fits into one helicopter load, and then they take you up. Now, when you're going up to Mount Erebus, it's very high. It's almost 14,000 feet high. So you actually have to go through an elevation acclimatization camp for a while. So you end up going to Fang Glacier, to the camp, and that's always an iffy place. And sure enough, we got there, and look at this, it's very clouded in. We decided we can go in anyway. It cleared up just as we got there. So we got out and got settled. I built my little mountain tent here, and the helicopters take off, everything cool, but then we have this storm starting. It fogs in, the winds start picking up, and the next pictures are no pictures because everything is so there's no visibility, and I'll show you in a minute how little visibility there is. So at that point, I decided I'm not going to go into my mountain tent anymore. I go into the Scott tents, which are much more livable because you can actually stand up in them. And so the mountain tent is cool for me because I'm tall and I can stretch out. In Scott tents, I can't quite stretch out, but I can stand up. That's very good when you're stuck there for a while. So that's my Thanksgiving feast. After 2 days, 2.5 days of storm, we had 85 miles an hour winds outside, couldn't go out. By that time, the water in the thermos was kind of lukewarm, and in that cup is some dried pea soup with lukewarm water and a cracker. And this was the worst Christmas Thanksgiving meal I ever had, so not to try again. So Lori decided that's what you do, and you basically go into your sleeping bag and you just sleep and hibernate. So that's what you do mostly. Every now and then you do other things. Now, in this case, I decided I really, really need to go to the bathroom. And so, it takes a while to get these boots on and the coat and all this stuff. And, you just go out and there are these tents have these hose type things that you seal up again, inside, outside. And you're outside, long ado. And then I go outside and Lori cries out and says, "Hubert, why don't you take a photograph?" And I said, I can't see anything. I was standing there and I couldn't see my hand in front of my eyes. So she said, just hold on. So she took her camera, held it out the tent, took a photograph, and that's her photograph of our ice axe, which was about a foot away from the camera, right? So at that point, I decided I'm not going to the bathroom. And I'm going to stop eating solid food, too. And so this thing lasted another 3 or 4 days, and we just basically stuck in this thing. I came back in. You sort of see my face is deformed from the wind. That was just like 45 seconds out in that storm. And I just, no, we're not going to do this. So when the storm was gone, I looked back at my tent, and it dutifully filled up with snow. Then the weather improved, and then we could go on the skidoos. The one of us who can ride skidoos went up with a skidoo to Mount Erebus, and the other one waited for the helicopter. Riding skidoos is fun. I mean, particularly in the mountains. And what happens is that the skidoos, you know, most people, many of you may have ridden skidoos on lakes, on frozen lakes, where it's flat, it's very easy. But then when you have a slope, your skidoo sits like this, and you sit on top of that, and you don't want to fall down. So what you end up doing is that you stand on that side of the skidoo, and then you hold the handlebars like this, and you ride it almost like a windsurfer. And it's really fun. I mean, once you know what you're doing, it builds up upper body strength, and it's very nice. So so this is, you know, what we did. So that's the lower Erebus hut where we stayed. That's inside the hut. You know, now we actually could have warm cocoa and coffee and anything. So it was very nice. But then every now and then we had to go out with the skidoos. And I don't know whether you can see this, but this particular day, I forgot to cover this part of my face. And I had frostbite right on the tip of my nose, just because I forgot this quarter of a square inch of my face. This is a Navy helicopter that sort of turned over some night. Nobody was killed, but that residue is still there with a backdrop to Mount Erebus. So this is our first Erebus site. It's called Tramway Ridge. It's a hydrothermal area, a lower one and an upper one, which is a protected area, and you have to go in there with suits. So you have to get sterile suits on and rubber gloves and everything. And that's a very tricky business because it's really cold. And how do you have sterile hands in there? You know, basically what you do is you just take your bare hands, put gloves on, and be really quick with your work, which doesn't quite materialize. But the cool thing was that while I was working there, I was actually working in the hydrothermal area, so the soil was actually warm. So digging in the soil was just actually kind of pleasant to my fingers. I was warming my hands in the hot soil. So this is an experiment we put out in, actually that was our cold site, because, you know, we took a cold site and a hot site, and we put our experiments in there. So the next thing is we were going into ice caves. And what happens is that the volcano is active, and there's a lot of hot air coming out in various places. And this hot air is saturated with steam, and it makes these columns, these ice towers. And every now and then there's a little hole down there, so you can go in there. So that's the hole from the inside. And then you can bring a ladder, you can go in there, climb in. And you see on this wet ice surface here is that it's glistening ice, so it's warm in there. So outside it's freezing, inside your glass fog up, your camera fogs up. It's very difficult to take photographs in there, but it's nice and warm. So it forms these caves, and that's the ceiling of the cave. And now remember what we did is we went there with snowmobiles. So this is the snow on top, and wherever you see light, that's where you do not want to park your snowmobile, right? This can be 30 feet down, so it's very dangerous. You have to be very careful. So anyway, so you find these rock crevasses or rock ledges and cracks where the warm air comes out. There's water dripping down from the ceiling, and so we put out experiments there. And then to make sure that we find the stuff back, I just took this fluorescent line and strung it all the way through this little cave. So next time we get there, we can find this thing back again. So that's another cave. This another thing, another hydrothermal vent. This time more in snow, and this is the entry to this. And as you go in there, you have to actually be very careful because ice can break out from underneath you. So you fully secure yourself right from the beginning. We have a mountaineer with us, a very nice guy, Nick. And he kept us safe, and so we went in there, and then we went into these caves, and then again find another place. And the nice thing is that, I mean, for geobiologists, what they're trying to do is they're trying to reach environments that have not been contaminated by people, right? So in these caves, nobody has ever been there before. And so as you go in there, you can clean yourself up, you can make sure that you're wearing gloves, and then you reach just with your gloved hands into these cracks where you put your experiments, where you take your samples. So it's actually an inside Earth kind of environment. And again, the same trick that we used with the lines. Here's just a few more pictures from other caves that I just thought they were kind of cool. This is just blue ice. You know, it's just wonderful to look up and you see this blue ice cave, and that's where regular light comes in from opening. There's more caves. More caves. Now, before we end, I want to take you back up to Mount Erebus, and as I do that, I would like to point out a panorama of Mount Erebus. That is right on top of Mount Erebus, and you can actually go to our website and download this thing and print it yourself. And it's very high resolution, and you can print this with good resolution even up to like 6 feet tall. So anyway, we went up there some night after dinner, and you see this magma chamber. This is the red magma down there, the ice towers. So what we ended up doing is that, you know, we went up there. You know, it's just, you know, once you know how to do this with a skidoo, it's really easy. You know, you just go up there. You know, it's really amazing because with a skidoo, you actually have to, you ride typically with 2 people, you have to sort of ride like this, you know, right on top of the handlebar, and so you don't tip back because it's so steep. And so at this point, I didn't really know what was going on, but our mountaineer was just saying, "This is perfect weather. This is wonderful. This is really cool, and it's perfect flying weather." And so, what is he talking about? And so he decided he wanted to do a first descent down from Mount Erebus. So we went down, we collected his glider, and the 2 of us, him and me, went up there. I dropped him off, and then he parasailed down, and first time ever coming down from Mount Erebus, and he was just so excited. And it's just wonderful to be able to do this. And I go to Antarctica almost every time I go there and do these kind of things. I'm saying, they're paying me for this. This is just most amazing. So anyway, that's it. Thank you. Well, the question is that global warming may have changed the climate such that the cans and the preserves that Shackleton left actually go through a major decay just because of climate change. And yes, they go through a bigger change, but it's mostly, I think, because of increased access. And I think those things are 100 years old. And the New Zealanders are making a great effort of preserving this, and this is a total science how they do this. It's really amazing. And you can hardly ever go to these huts without any curators being there doing something. So they're very aware of that. The question is what we put out as bait for the microbes. And the idea is to study how microbes eat rocks, and we stick with volcanic glass because that's where we made most of our observations, also because it's a material that's relatively easy to attack chemically. And then what we did is that we augmented the composition of this glass in various ways. Like one is we put apatite in this, which is a phosphorus-rich mineral, and life needs phosphorus. And so that's one substance. Another substance is where we enrich the glass with manganese. There are a lot of manganese oxidizers, reducers that like to eat manganese. One of our leading hypotheses is that we're using the reducing energy of basalt for oxidation, for redox reactions. And so we contrast the glass that consists almost entirely of oxidized iron, or where all the iron has been oxidized, and somewhere it's mostly reducing, like in most basalts. So our hope is that these different compositions of glass will attract different kind of microbes. The question is how we avoid contamination with our experiments. What we do is we we sterilized things thoroughly beforehand, and we checked everything for sterility. But then once it's out there, there's no easy control. So you just have to see. But I think if you get consistency, if you get different microbes for different nutrient values, you get closer to identifying the real assemblages there. And we'll also compare this with the basalt. But note that these areas, nobody goes there. So there's no or very little human contamination. Particularly in the caves, we're pretty sure that there's nothing there. And it's really up to us to be careful and not contaminate. Okay?
Thank you very much, Hubert. I'm sure it's